Welcome to this explainer on Meridian, an orchestrator built to finally cure the context window bloat that absolutely plagues long, multi-step AI agents.
Section 1. Context bloat kills agents.
If you're building agents, you know the wall I'm talking about. You give an agent a big goal, it accumulates old tool outputs, and resends its entire history on every single step. It's a complete death spiral. The context fills up, your cost balloon, and boom, the agent dies. Teams end up babysitting these runs, burning real money on work that just never finishes.
Section 2. Spend minimum, manage maximum.
Meridian fixes this autonomously through one simple core thesis: spend the minimum to manage the maximum.
Basically, most of the machinery for staying alive, stuff like token counting and stall detection, is completely free and deterministic. You only pay for expensive model calls when you need genuine reasoning.
Section 3. 7-node agent architecture. Let's move through this fast.
Meridian pulls this off using a highly structured, stateful 7-node graph. First up is Ingest. This is a completely free, deterministic step that maps your codebase and builds the work queue.
Next is the Executor. This analyzes a single code file at a time, which does cost a model call.
Then, the router deterministically scores that file's complexity. It routes easy files to cheap models and hard files to the expensive ones.
Meanwhile, the budget monitor sits silently in the background. It's a free, ambient trigger that recomputes tokens and context fill after every single step.
Now, if that context gets too heavy, it wakes up the compactor, paying a model call to compress all those accumulated findings into a tight brief while dropping the useless raw prose.
We also have the progress judge, which deterministically watches for endless loops. It only spends a model call to confirm if a stall is genuinely ambiguous.
Finally, the synthesizer writes out your final documents, or the stop node cleanly halts the run before it burns through your wallet.
The crucial takeaway here is that the working context stays incredibly tiny, while all your full results are continuously saved into a durable checkpoint on disk, so nothing is ever lost.
Section 4. Head-to-head live demo.
Let's look at the actual proof. We ran a head-to-head run on a 32-file Python codebase. Both agents have the exact same goal: read the codebase, then produce architecture and issues documents. On the left, we've got the naive agent. Watch closely. It just mindlessly resends its entire history to an expensive model on every single step.
Its token usage and costs are climbing aggressively right now. Look at that context bar. It is absolutely rocketing toward the red cap.
And, unsurprisingly, it hits the wall. It completely fails at file 19. Budget burned, no finish line.
Now look at Meridian over on the right. The budget monitor is tracking everything, and right there, you can visibly see the context bar drop as the compactor compresses the history.
Because it routes intelligently and tightly manages its own state, Meridian's context stays perfectly flat, and it easily completes all 32 files.
Section 5. The final results.
The numbers from this run are definitive. The naive baseline failed at file 19 with a 100% full context window, while Meridian completed every single file and kept its context hovering right around 20%.
Looking at the spend, the naive agent burned $0.0227 before dying, whereas Meridian finished the entire job for just $0.0088. That is exactly a 61% cost savings on a task that actually finished.
It also saved about 23,000 tokens of compute in the process.
And quality didn't take a hit. Meridian successfully produced the architecture document and caught all 16 planted bugs.
Section 6. Containerized for deployment.
Taking this from a local demo to production is incredibly straightforward. The whole agent is containerized with a Docker file, deploys natively to Google Cloud Run, and exposes its telemetry securely via a custom MCP server.
Meridian proves that by forcing an agent to manage its own budget, we can finally run long, multi-step tasks that finish cheaply instead of failing.